right? uh, Amplitude and frequency. What is amplitude? Amplitude is the vertical fluctuations, we can say. The vertical line is the amplitude and the time. Okay, this part is the time, this is the frequency. How many cycles is generated in the time. Sorry. This is the analog. Analogs having this amplitude and the frequency. Let's see this digital transmission. Digital are much simpler than analog signal. Instead of continuous waveform, continuous, we say that analog is a continuous. Okay, analog signals are made up of the series of pulses and that present either a bit zeros and one. So it's a little bit simpler than the analog signal as compared to digital. It's based on the pulse, zeros and one. Its computer systems use coding systems which define the combination of zeros and ones make up of the characters in the character set. Data zeros and ones are carried out the network depending on whether it is an electrical or optical transmission. So it's in the form of zeros and one. And there are different types of the conversion of this analog and digital. Let's see first this digital to analog conversions. When data from computer is sent out to via an analog carrier, it is first converted into an analog signals. Other signals are modified to reflect digital data. So these are the things in this analog to digital. When data from the computers, so all those devices are the digital in nature. Computer, laptop, tablet, mobile phone, all are in digital form. Okay, data are processed in the digital format, zeros and one only. But we needed to send out the data to communicate with each other. Then it's sent out in the form of analog carrier. So it's first converted into these analog signals. Analog signals are modified to reflect digital data. So it's reflected the digital information in the analogs. Okay. So how to represent those digital into analogs, that we'll learn in this one. An analog signal is characterized by its amplitude, frequency, and phase. So these things are important in this communication. Analog sorry, analog to digital conversion. So it's converted into different phases, different form. Not in this. Amplitude, frequency, and phase. Okay, these are the three forms. Okay, these are using these three forms, it's modulated the signals. Okay, so amplitude I already explained, then frequency already explained, and phase. What is the phase? In each and every cycle. Okay. In each and every cycles we have a different phase, okay, different degree, 0 to 90, 90 to 120, and 120 to 180 to 270, and 270 to 360. Okay, these are the phase. So based on those things, we is converted the signal analog to the digital. There are three kinds of this digital to analog conversion. One is amplitude shift keying. Amplitude shift keying is a variation of this amplitude. Okay, absence of amplitude and presence of amplitude. Here in the one, it's present the amplitude. Okay, this wave is presented. Represented this is one. If it's present the amplitude, frequency still exists, time still exists. It's vary the amplitude. Okay, it's changed the amplitude. 0, there is no amplitude. 1, amplitude. 0, no amplitude, and 1. Also, this is the amplitude shift key. And in the frequency shift keying, that's amplitude is constant. There is no change in the amplitude. Okay. In this amplitude shift keying, frequency is constant. There is no high frequency, there is no low frequency. It's same, but it's changed in the amplitude. But in the frequency shift keying, the amplitude is constant and it's vary the frequency. Here we have a high amplitude in 1 and 0 low amplitude, means here frequency is high. In this time slot, here we have more frequency, more cycle, but using this time slot we have less. Okay, high, low, 1 0 1 0 1. Like this we have our amplitude shift keying and phase. Okay, before this phase shift keying, amplitude frequency shift keying, we have two types of frequency. I have to explain this one. In this frequency shift keying, the techniques use two frequency. Okay, high frequency and low frequency are implemented in this F1 and F0 frequency. So if it is 0, then it's use the low frequency. If it is 1, then it's use the high frequency. Then it's alternately use the high and the low frequency based on the digital data. Okay. So this is the thing in this frequency shift keying. Let's move on to the phase shift keying. Phase means it's change in the in some phases. It's use the amplitude and then the frequency is still constant, but it's change the phase. Okay, here we are using this frequency, the same frequency cycle. Here is cycle is completed and it's coming to the next cycle here, and it's changed the number of the binary. Then if it's transition here, okay, at some point, then it's changed the phase. Instead of continuously going to this, then it changed the phase here. Okay, like this. Here it's changed the phase again, and this is 1 1. There is no changing in the binary value, then it's continuous here. Then here it's changed to 1 to 0, then it's changed the phase again. So this is the phase. Okay, phase amplitude. This is these three are the digital to analog conversion. Okay. Amplitude shift keying, frequency shift keying, and phase shift keying conversions. Okay, modulations. Let's move on to this analog to digitals. At the end of the transmissions, how we get it back this analog into original binary data. That's the things again. Microphone creates analog voice and camera creates analog video, which are treated in analog data, so it's transmitted in the form of analog. To transmit this analog data over digital signals, we need analog to digital conversions. Learn it, this one, complete this one. Then at the at the destinations, at the transmitting end, we need to convert it back. This is called unlock to digital conversions. Unlock data is continuous stream of data, is a waveforms, whereas digital is discrete, 0 1 0 1. That discrete suddenly change of this frequency. Okay, so how to convert this one? To convert those analog wave into digital, we use pulse code modulations. You have to remember this. Okay, this is the technique for converting this. Okay, pulse code modulation, PCM. What pulse code modulations converted back those original data binary forms. Okay, PCM is one of the most commonly used method to convert this analog data into the digital forms. It's involved in the three steps. Okay. How it's convert those analog data into the digital format? We need three. Okay. Number one is sampling. We needed to have a sampling. And the second was the quantizations. We need to quantize the sample frequency. And the next one is the encodings. We have to encode these quantizations. Here we have the original sine wave signals. Then this is sample. It's take out the sampling of from this analog signals. Say suppose here we are having this sine wave. Okay, sine wave means analog signal. Then here in each at every point we have a sample. Okay, binary samples. The signals is sampled every t times, every time intervals, every times. So in this time between samples again, some time interval, sample. Okay, based on the time interval. Most important factors in sampling is that the rate of which analog signals are samples. According to the Nagus theorem, the sample rate must be less 2 times of the highest frequency of the signal. So taking sample is very important in this analog to digital conversions. Why? If you take too much sample, then it's create problems. There's lots of duplicacy and all those things are there. Here, if we take a sample in between these 10 samples here, then there's lots of duplicates are there. Okay, and if you take a very less samples, take sample here and another sample here again and another sample here again at last, then in between this there's lots of loss of signals. Okay, so how much sample we are going to take, this is classified by the Nagus theorem. Okay, Nagus theorem. What Nagus theorem state? Nagus theorem states that the sampling rate must be at least 2 times, okay, of the highest frequency of the signals. So these signals having the frequency maybe 2 kilohertz, 3 kilohertz, 5 kilohertz, 400 kilohertz or something like this. Okay, if it is 2 kilohertz, the highest frequency is 2 kilohertz, then what will be the sampling rate? The sampling rate should be 2 times. Okay, 2 times of the frequency. Highest frequency is the 2 times. If the frequency is 2 hertz, then we have to take 4 samples per frequency. Okay, so this Nagus theorem is very important to take the samples. Okay, and let's move on to the quantizations. How quantizations coming up? Quantizations is nothing much. It's remove the analog signals, then it gets only the samples. Okay, sample informations only. That here we have different types of level of the analogs. Okay, each and every level having the binary value. in this amplitude. Okay, quantizations. And sampling yield discrete from the discrete form of continuous analog signals. Every discrete pattern shows that the amplitude of the analog signals at the distance. This quantization is done between the maximum amplitude value of the minimum amplitude values. Quantization is approximation of the instantaneous analog value. So from the analog value we have the quantization coding quantization values. This is the instantaneous values. So each and every quantization value having the representation. The first quantization's value having this binary informations, this also having this binary value, and this one also having the binary value. This is called the encoding. Okay, from the quantizations. And and in coding, an approximate value is converted into the binary format. So in the encoding, that's it's represented into this binary value. That is the thing involved in the pulse code modulation PCM in analog to digital conversion. Okay, we can move on to this multiplexing. It's very simple, that multiplexing techniques which by which different analog and digital streams of transmission can be simultaneously processed over a shared link. Without multiplexing, we have to transmit it in a separate dedicated line. If we are having the 100 nodes to transmit from one source to another, then we need to have a separate cable of 100. Okay. What is the advantage of multiplexing? Multiplexing techniques in which different analogs and digital signal of transmission can be simultaneously processed over a shared link. So instead of dedicated 100 link from source to the destinations, then we are having a main trunk shared line, single line. Then it shares this single line for transmitting from one source to the another receivers. Okay, multiplexing divide the high capacity medium into low capacity logical medium, which is shared by the different streams. So it's shared this high speed by the low speed devices or node. Communication is possible over air, radio frequency using the physical medium cables and light opticals. All mediums are capable of multiplexing. So frequency, whether frequency or cable or the optical fibers, it can implement by using this multiplexing. When multiple sender try to send over a single mediums, device are called multiplexer. It multiplex into a single channel. Okay, device by the physical channels and located one to each others. On the other end of the communications, that it needed to convert it back those single channel into the multiple part. This is called the multiplexing. Okay, that's clear. Under this multiplexing, we have different types of different types of multiplexing. Look, normal mero. Oh, Saran. Oh, tadi Sanjeev. Look, class ko la lo. Class ko nila lo. Oh, mero. Okay. Frequency division multiplexing. It's divided into the different types of frequency. Okay, then this frequency is sent into a multiplexing, frequency 1, frequency 2, frequency 3, and in the demux that it demultiplex again all this frequency into this. Okay, but one more thing, if we send all this 1, 2, 3 frequency at the same time without splitting this one, then it's collide with each other, it's interfere with each others. Then in between this frequency we needed a guard band. Okay, guard frequency. Guard band means there are small frequency allocated in between this frequency to protect the interference with each others. Okay, and the next one is the time division multiplexing. In this time division multiplexings, we needed to have a time to send the data. Okay, time divisions. Okay, so time slots are maintains both the end of the multiplexer and the multiplexer. Okay, time slots are maintained, each and every station having a time slots. Okay, so digital signals are divided into a frame. To transmit to the time slot, we need to have a frame equivalent to the time slot. Frames are automated size that can be transmitted in a given slot. So each and every frames that the data is sent from this node. Okay, from the node. TDM is a synchronized mode, so it's needed to synchronize. Why? This is time based. This multiplexer and the multiplexers needed to have a time synchronizations, same time. Okay, so that's why it can send and receive the informations using the frame. Okay, here the example of this multiplexer and the multiplexers. So here we have a time slot. Based on this time slot, time and this the multiplexer receive sent by the multiplexer. And in the fiber optic communications, wave division multiplexing is still there. In this wave, that wavelength color is very important. Wave color. In fiber optic mode, multiple optical carrier signals are multiplexed into a optical fiber using different wavelength. This is an analog multiplexing techniques and is done conceptually in some manner of this frequency division, but also light as a signal. So it's almost same with this frequency division multiplexings, but it uses this color, okay, for sending this one. It receive the multiple color, then it's send this color and it's demarks by using this wavelength of the color. Okay, these are the multiplexing. Okay, first we have for time division multiplexing, frequency division multiplexing, and also wave division multiplexing. And let's go to the switching. Okay. Okay. Still left, still more left is switching, circuit switching. Let me complete this switching. What is switching is very simple. It's process of forward packets coming into in form of the port or the port leading toward its destinations. When data comes on the port is called the ingress. When the data leave the ports going out is called the egress. Okay, ingress and egress, coming in, going out. Okay, you have to remember this point. Okay, ingress, what is ingress and what is egress. A communication systems may include a number of switches or not. At board level, switchings can be divided into two major categories. Okay, switchings is it switch the signals in a different port based on the port numbers and all these things. Then the incomings is called the ingress, then the outgoing is called the egress. Okay, then the switching is divided into categories. One is the connectionless and one is the connection oriented. What is the connectionless? Data is forwarded on behalf of the forwarding tables. No previous handshakings is required and acknowledgements are optional. So it's forwarded on behalf of the forwarding tables in the in a normal network switch, having this forwarding tables, make forwarding tables and all these things. Based on this is forwarded the signals. But in the connectionless, there is no handshaking. Handshaking already explained this one. There is no error checking or error corrections or acknowledgement whether the data is received safely or not. There is no checking mechanism in the connectionless. Okay. Opposite to this connectionless, we are having this connection-oriented things. Before switching data to forward to destination, there is a need of pre-establishment circuits along the path between the both ends. So it's create a virtual path, we can say, in the switching. Okay, that's here. There's some virtual path maintenance. Okay, then in this virtual path, after connection is established, then it send the data in this virtual path. Okay, there is no physical communication, exact physical connection on this. In between this, there are jumble of connections are there, but before actual transmission, then it's create those things. Okay, in the connection oriented protocol, pre-establishment circuit. Okay, data is then forwarded on the after transmission of completed circuit can become be kept for futures use or can be turned down immediately. This is the three-way handshaking also in the TCP IP also. It can terminate first establish connections, data transfer, and termination of connection. So this is connection oriented in the circuit switching. In this switching. Okay, let's move on to the circuit switch point. Not communicate with each others, and over decades communication path, it's called circuit switchings. There is a need of pre-specific route from which data will be travels, and no other data is permitted. These circuit switchings to transfer the data circuit must be established so that the data transfer and can take place. So circuit switchings is our telephone communications also. In your mobile phone or in your normal generic telephone lines, if you dial the numbers, then it establishes the connections, it's established the circuit. So in between this, if there are someone trying to call your number, then it's not possible to connect to you because your line is engaged. This circuit dedicated. Okay, it's dedicated for the two parties only. In your mobile phone also you can dial your friends. Okay, you can dial your friends, but while talking with your friends, then some other guy try to communicate to you, then it's received the engaged tone. Okay, so this is fully dedicated circuit switching. Circuits can be permanently or temporarily. The applications which use in circuit switching may have to be go through three-phase establishment, transmit of data, and disconnections. Same with this tree handshaking. These circuit switchings can be a permanent or temporarily. Permanence means it's create a virtual circuit permanently from the node to node, from sender to receivers. But in temporarily, it's established the circuit, data transfer, and terminate it. It's temporary. Okay. Okay, that's circuit switching was designed for voice communications. So in our voice communications, our mobile phone, 3G GSM network, and then telephone line, PSTN network. All these things are using this circuit switch network. Telephone is the best suitable example of the circuit switching. Before users can make call, a virtual parts between the caller and callee is established over the network. That's clear. So it's established the connections. Okay, now we finish the unit 2 right now.